Howdy folks, today we're looking at a Mitsubishi DA-R20. These don't seem to be as popular as, Pioneers and Sansuis, let alone Marantz, but it is a pretty slick looking receiver in my opinion, especially when powered up. I think it looks pretty cool. It's from that very early 80s era where you had both digital and analog tuning, which is kind of fun. You can kind of see that do its thing. This particular receiver has a little bit of a reputation for having a solid tuner on it. So folks who are into actually listening to radio, this is a good model for that. They're not known for having really great bass, for being very warm. They're known for good high end and being articulate, precise. So they don't add a lot to the sound, but they do reproduce audio very accurately. This particular unit came to me because there's something wrong with the output stage, according to the prior owner. This thing uses STKs, not unlike the Technics amps that we've played with, but this one uses 1060s as opposed to the 0050s or 0039s from the Technics integrated amps. This one, I can show you what it does. So if we give it an input source here, put it on phono. So you can hear the distortion there probably off the top. It's really bad on the left. And then on the right, we can get more volume out of it on the right, but it goes into protection after a little while. So you can hear that distorting. I don't want to push it hard enough to get it into protection here. And then as the amp runs, the longer the amp is on, the quicker it goes into protection as you give it volume. So whatever the issue with it is gets worse as it gets warmer. So it's gonna be kind of fun to play with. Let's see, anything else to say before we take it apart? I don't think so. So yeah, let's go ahead and start tearing into it. So as you can see, we have real easy access to the STKs here, and they're mounted on a big hunk of aluminum. So I don't know if it's a good thing or a bad thing that they made the STKs super accessible. I mean, it's nice to work on them, but I wish they would have had a little more confidence that the design worked and didn't need to be, serviced. But such is the way. Let's see if I can give you a look in here. Yeah, it's not too dirty. It's not bad enough I'm going to put it in the dishwasher, I'll tell you that. Probably just blow it out with a little bit of air later on. And that'll be about all it's going to need for cleaning. See a little tuning capacitor doing its thing. That all works well. Let's see. I like the little shielding here. It's fun. Yeah, not a whole lot to see here. So I think I'm gonna do next is see if we can do some testing on the STKs, which means we gotta plug it back in, power it up. So I've got my little data sheet here of what the pins should be at. This is, of course, powered on with the volume all the way down. So our power rails are plus and minus 50 volts on pin 9 and pin 2. So if we look at pin 9, pin 9 should be 50 volts. Let's not cross it with ground. Okay, it looks like we've got 50 there. And then pin 0 should be at 1.2. Got right about a volt, that's in the ballpark. Check over here. All right, it's about 51. And pin 0 is at 1.5. Interesting. Okay, we're gonna jot down some values here as we go. So these that I've kind of scribbled out here have no connections in the schematic. All right, so got some interesting characteristics here. The getting 1.5 positive over here is definitely wrong, and the minus 43 is off as well for the power rail. So we may have some problems with the supporting circuitry on this guy. Or it could potentially just be that it's so screwed up that it's causing the problem. So, but we'll do some digging in there. I need to look and see if I can play the same resistor trick between 1 and 3, 8 and 0 that you can with the other STKs. These have a built-in emitter resistor, so I'm not sure what all's different there. I'll have to do a little bit of research to figure out how to properly test the support circuit there. Let's see. I may try swapping these two and see if the problems move around or not. It's another way I can do a little bit of diagnostics there. So either way, I'm going to have to take these out, so I think that's going to be the next step. That's just gorgeous. Glad to see that, you know, we're being very consistent on screws here. If you look, we've got machine screws, we've got some nice pointed sheet metal-y type screws, we've got some flat-faced sheet metal type screws, and then we've got this really, really stripped out guy. Glad to know that that's super consistent there. Okay, so now with that off, we can get to the bottom of the STKs. Probably, let's see what I can move around to give you a better view. So we're looking at these right here. Looks like this guy may have been worked on in the past, just judging by how messy that is. And you can see here the 3 pins that aren't connected on each of them. So that's 3, 5, and 6 are not connected. And then you can also see that 4 and 7 are connected together. Let's see, 4 and 7 here, sharing common trace. So yeah, I think we're going to go ahead and pull them out. Doesn't look like that one had a good thermal connection at all. That would explain that channel dying if it wasn't getting good heatsink. That one looks like it had a much better thermal connection. So I don't think with the emitter resistor in here, I don't think we can do the 2 and 3, 8 and 9 test, but I'm going to do it anyway. See what happens. And plus, this thing isn't just you know, straight not working. And nothing on 2 and 3. Interesting. 8 and 9 are together. 2 and 3 are fine. 8 and 9 are shorted. 2 and 3 are okay. 8 and 9 shorted. Let's see how it is on the new ones, because yeah, that might just be how it is. So one of my goals with this project was to explore a little bit on building discrete replacements. But as I was digging around, I actually found a set of what I think are originals. I am not completely positive, but they look very, very similar. The couple of things that lead me kind of this direction are the originals are numbered, and all of the reproductions that I've seen do not have the pins numbered. Weight here's about the same. I know the weight tends to differ. Let me see if these can actually throw them on a scale and see if they weigh the same. So I would expect the ones that we just pulled out to weigh just a little bit more because of the thermal compound on them. So you're 28 grams, you're 28 grams, you're 28 grams, and you are ish 28 grams. So the reproductions that I've seen for the 0050s and the 0039s weigh a couple grams less than the originals. And also, if you look, the lettering here on the back looks pretty similar, and even the kind of serials here, 160, then D, then it's getting into it. It looks like these are quite likely original. So I can't guarantee it, but it seems like there's a good chance. So let's go ahead and check out. Let's see, were we going this way? Let's see, it was 8 and 9. That's, yeah, crossed on both of them. Let's see, that's actually 2 and 3. Sorry, 2 and 3 is on this side because the numbering's reversed because they're upside down. So 2 and 3 here. Nope, all good. And then 8 and 9, all good. So maybe you can do the 2 and 3, 8 and 9 test on these things. Oop. Okay, so the next question is, do we want to just put in the replacements and see how it works and risk killing them? Or do we want to see if we can play the resistor game? Let's play the resistor game, and let's see. Let's see. Actually, it doesn't make any sense in this circuit because, let's see, if we look at these things, the resistor goes between 1 and 3 and then 8 and 0. But 3 isn't connected to anything on this guy, so I could just put 1 in right here, see what that does. You know, kind of a little bit in uncharted territory here because there aren't a lot of this receiver around. But let's give that a try. I had the 1Ks that I'd used for this before sitting around here somewhere, but I seem to have misplaced them, so gotta dig into our stash of known good 1Ks. Okay, so we now have our 1K resistors across. So if you look here, like so, they're across 8 and 0. I didn't bother doing the 1 and 3 because 3 isn't connected to anything. So I'm going to take my readings now. We're going to plug back in and turn it on. Hopefully nothing terrible happens because this isn't exactly the same setup I've done on others. And we will take some readings across, and yeah, we will see if things, you know, at least look the same on both sides. So we will jump in. All right, so looking at the chart here, this is with them removed. Got -50, where we've got nothing connected on both sides. Basically both sides the same, 0.35, 0.4, close enough, 1.1 to 1, close enough. Some people might say not close enough, but for me, close enough. 50 here, and then 1.1. This is, again, because of our resistor going across there. So, yeah, I think I'm going to say that the supporting circuitry is close enough. We either have the same problem on both sides, or it is the STKs that are bad, and one of them worse than the other, which lines up with the symptoms that we were getting. So let's turn it back off, unplug it, take the resistors out, put the new STKs in, do a better job of getting a thermal connection so that we don't have this problem again. You can see that it's mostly was never contacting the heatsink. So we'll do a better job than that. All right, so the goal here is to have it thick enough on there that there are no dry spots where, you know, you just don't have, where you either have basically where it's floating and there's no, you know, metal to metal or thermal compound to metal contact. You want to have it just completely coated. So that's what we've got. And now we can drop these guys in. Or not. Amusingly, these have the opposite problem of the Technics. So you'll notice the pins are not bent. They're straight as opposed to having them go into the middle. And on the new ones, they are pre-kinked. So we're going to have to straighten all of these out. All right, I think that should be adequate for our purposes. Now let's power it up and see how she does. That's a good start. Okay, relay's kicked in, that's good. Let's try the tuner. All right, that seems to work fairly well. Let's see, I don't want to do any of the listening tests with the radio because of course I don't have the rights to use any of that music. So let's go to Aux and listen to a little bit of PowerPCMe. Interesting inverted loudness knob here. All right, that seems to work as expected. Let's jump over to phono. All right. I would call that working across the board. I am pretty happy with how that came out. And yeah, I think this one, as you can see, it's fairly clean inside. It looks pretty good on the face. there's really not a lot else to do to it, so I think this one's gonna go on down the road. So thank you as always for watching, and we will see you in the next one.